regions mean? Regions is about posing the question. Start again. Asymptotes are about posing the question. What are sort of my guidelines? Sort of like lane markings, if you like, that I have to obey. I've got to stay between them. But regions is about where do I actually have to be? Where do I have to pass through? Okay. So before I get to regions, let's just do a little thought experiment. Okay. Come in. If you have two numbers, you don't know what they are, their values, okay? But I tell you that both of the numbers are positive, okay? If I take the product of those two numbers, what do you know about the product? It will also be positive. There's no way either of those can go negative, okay? In the same way, if I told you one's negative and one's positive, you know that you'll get a negative, right? By the same logic, if I had like three numbers, and I said two of them are positive, and one is negative, you would know that the product is negative, okay? Now, we're thinking about numbers, yeah? The same works for functions. So, let's think of a simple example. X plus 1 over x minus 1, x plus 2. Let's think about this thing, okay? Actually, do me a favor. Draw yourself a set of axes underneath this. No, I think. We're going to keep going after this. So. Now, we were talking about numbers before, right? And I've got some division here. Don't forget, division and multiplication, they're really the same operation, just in reverse, okay? So if I look at these three, I've got three functions here that make up my function. Much like before, we had three numbers that made up the number we were really interested in, okay? So I want to think about the behavior of these things. Now, unfortunately, these numbers don't just stay put, they change, they're variable. X plus 1 will change as x changes, okay? So I have to think about these as they pass through these different states. Sometimes they're positive, sometimes they're negative, okay? So, get out another color and take these three lines, x plus 1, x minus 1, x plus 2, and graph them onto your plane just in light pencil, okay? So I've got x plus 1. Yeah, because it works. It works. Okay, I don't have to make it beautiful. And then I think, okay, as I go from left to right, what's happening to these three functions? How are they changing? What does that mean for my my y, the whole thing, which is what I'm interested in, okay? These three lines break up our graph into different sections. Sorry, I missed. Anyway, you get the idea. Okay? So hopefully this is familiar for some of you, right? All the way on the left, right? I've got three numbers. See how why I did the pluses and minuses, right? I have three numbers and they're all negative, right? Negative times negative times negative is negative, right? So I know over on the left-hand side, this is where the graph will be. Okay? That's the region I've shaded. Now, as I cross over this border, I've got negative, negative, positive. These two negatives will cancel, okay? And I'll be left with a positive value. And in fact, every time I cross a border, I just switch, right? And off I go. Okay? That's what we mean by shading regions. I apologize, my colors are not very clear, but let's just quickly finish this off. What can I do with this? Okay? You can already read off the vertical asymptotes, right? Yeah.
Why are there three asymptotes?
I didn't say there were three asymptotes. I'm about to work out what my asymptotes are. There are no asymptotes in this graph yet. Haven't said anything to do with asymptotes on the graph. Careful. I'm working out regions. Different question. Careful. Okay, shh, stay with me, okay? What are my vertical asymptotes, guys?
1, negative 2.
Thank you. So, 1 is here, and negative 2 is over here. Those are my asymptotes. Degree of the top is 1. Degree of the bottom is 2. What kind of asymptote am I going to have? I've got my vertical ones already, and I'm going to have horizontal or oblique. Which one? Horizontal. Horizontal where? Thank you. Okay, I've got my lane markings, okay, which is the asymptotes. I've got the regions I'm going to pass through. That's sort of all we need, almost, as you'll see in a second. 1, 2, 3. That wasn't so hard, was it? Can you see? Once you've got your asymptotes and you've got the regions you're in, there's nowhere else this function can go. It's got no other choices, okay? You can try and do some wiggly shapes, right? You're like, maybe this comes down here, but it won't meet the other regions, okay? So regions is about working out positives and negatives, okay? What you want to think about is these 3 bits here. Now, one quick question. Suppose I change this top one, x plus 1, into x squared plus 1. How would that change the regions that we graph? Because I can't factorize that any further. What would I do? I'd draw the parabola, okay? Now, in fact, short of drawing the parabola, I can do better than that. I can forget about the parabola. Just think about this, right? I've got x minus 1, right? X minus 1, which is down here. I've got x plus 2. And x squared plus 1 is not just any parabola, it's positive definite, right? It never touches the axis. It's always up here. So how does that affect the sign of my graph? If it's always positive, it has no effect on the sign. So it would be up here, but I can just ignore him, okay? If it was negative, I would have to put him in just to watch out for him, because he'll flip everything, okay? Jerk, you know. But here, he's always positive, so I can disregard, all right?